Okay, so since I've already heard a couple questions, let's talk about these four, and then I've got a couple more examples that I can put up so that you guys can practice getting there. So on part A, how did I get the x minus 5 and the x minus 9? Roots are 5 and 9. And factored form, you do minus your roots. So just using that information alone, I would know that I need y equals a times x minus 1 root times x minus my other root. Are you guys okay with that so far? So then there's just that matter of how did I get the 3? 3 is in the spot where a goes, right? What other information did they give me other than just the roots?
6 and negative 9.
6 and negative 9. Yeah. Coordinates on the graph. So I'm going to put 6 in the place of any x that I see. So 6 would go here and here. Minus 5, minus 9. How else do I use that coordinate? Goes in for what? Goes in for y. And now we're going to work backwards and find that a value. So I still have this negative 9 over here equals a. Thank you. A is being multiplied to these parentheses. What's 6 minus 5? 1. Times 6 minus 9, negative 3. A times 1 times negative 3 is negative 3a. Then we divide both sides by negative 3 to get the a all by itself. What's negative 9 divided by negative 3? Positive 3. That's where I got that 3 in the front from. Does that make sense?
Yeah.
Okay. Similar idea on part B. What did they tell me here? A is negative 1. What else did they tell me? C is 3. What form are they talking about if they're giving me A and C? General form. So I would have y equals negative 1x squared plus bx plus 3. So what happened to that b value? I have to find it. I'm going to use this ordered pair right here. I'm going to put negative 1 in for x. So negative 1 squared plus b times negative 1. What are we putting in for y? I'm not done yet. You're welcome. What am I putting in for the y? The 2. I'm sorry, dear. What does it mean to square something? Multiply it by itself. So what's negative 1 times another negative 1? Positive 1. So I have negative 1 times positive 1. When I multiply these two together, I get minus b plus 3. Yep, 2 on the other side. What is negative 1 times 1?
Negative 1.
Yeah, negative 1 minus b plus 3. Can I combine anything together?
Add, subtract 3 to both sides.
I can subtract 3 from both sides, so that'll make it cancel over here.
So it would be -1 equals -1 minus b.
And then if I add 1 to both sides, I get that negative b is what? If I add 1 to both sides, 0. 0 is equal to negative b. So that means that all the way back here, I know that b is 0. Well, what's 0 times x? Just 0. That's why my final answer here doesn't have a b term in it, because it's a 0. Same kind of plan here. I know my h and my k, 3 and 7. We subtract h. Technically speaking, I still have that a term in the front, right? Yep. We're going to put 0 in the place of the x. Sorry, I put that in the place of the y. It goes in the place of the x. And what do I put in the place of the y? 16. What would I do first over here as I'm trying to clean it up? Yes, ma'am.
I have a question. So does it matter which one you use for H and K and X and Y?
Yes. So
Oh, you can only use the vertex for X and H and K.
that's absolutely correct. Only your vertex can be used for H and K. That's absolutely right.
Okay.
What can I do over here? Think about order of operations with me. What can we do?
So it's
Parentheses first. So what's 0 minus 3?
-3.
Negative 3. And we're going to square that, right?
2 times.
Negative 3 squared. So negative 3 times itself.
It's negative. It's
Positive 9. So that would give me 9a plus 7. Sorry, I realize I'm writing over those words there, and that's kind of confusing. Equals 16. So now if I minus 7 from both sides, what's 16 minus 7?
9.
9 equals 9a.
y.
Divide both sides, so I see that a has to be a 1. So I didn't write that down up here, but you could put that 1 right there. If your a value is 1, you don't have to write it down.
Let's go.
Yes,
Another question.
absolutely.
That there's wouldn't we also just add the 1 to each on the A and leave it like that, or do we have to do the steps to get to it?
You have to find your a value because they didn't tell us at the beginning that our a value was 1. So like back here on the first problem, if you'd written it down just y equals x minus 5 and x minus 9, that wouldn't be fully correct. We had to figure it out. And on that one, our a value wasn't 1. We got lucky on the third one. It was 1, but we didn't know that to begin with. Yes.
How did you get 16?
How did I get the 16 that's written in green right there?
Yeah.
From this y value right here.
Oh,
Because they gave us an ordered pair, and so we use that to put in for the x and the y. Does that make sense?
yeah.
Do you guys want to see me do part D, and then I'll put up some other examples for you guys to try on your own?
Yes.
Okay. They told me a root here. Whenever they tell me a root, what form do I want to be using?
General.
G-
Factor.
Factored form. When they give me roots, I want to go with factored form. Factored form has an a value, but they told me that a value, right? So just using what they gave me, I would have y equals 1. And then, let's see, one of my roots was 1.7, so we always subtract the root that they give us. But then I didn't know the other root. I didn't have enough information for that. But what else did they give me to work with? The coordinates. So I'm going to put 3 in the place of any x that I see. Since my a value is just a 1, I'm going to stop writing it from this point forward, because if your a is 1, you don't have to write it down. Do I have anything to put in the place of the y?
Yes.
What do I have?
6.5.
6.5 I'm going to put in the place of the y. Okay.
Where did you get 2 from? You explain that again.
Up here,
Yes.
that's what we're going to be finding. This is my final answer. So right now what we're doing is we're finding this. Can I simplify these parentheses right here? Yeah. What is 3 minus 1.7? 1.3. And then I still have these parentheses. 3 minus R2 equals 6.5. What's going on between the 1.3 and the parentheses? Multiplication. So I could distribute, but that's going to make some of my numbers really gross. So what could I do instead if I didn't want to distribute, but I still want to get rid of it? What undoes multiplication? Division. So I can divide by 1.3. What is 6.5 divided by 1.3? Need to grab a calculator. I don't know off the top of my head. Yeah, that does come out to be a nice whole number. We get 5 equals 3 minus R2. What would you do to both sides? Divide? Subtract 3 from both sides. So I get 2 equals negative R2. Now I would divide. I'd divide by what? Negative 1. So I get that R is negative 2, or sorry, R2 is negative 2. So I would have X minus negative 2. What happens when you subtract a negative number? You get a positive. That's how I ended up with a plus 2 right there. Does that make sense, Sydney? Sort of, kind of, a little bit. Or are we just clear as mud? That last one is kind of messy. I'm going to put up 4 more that are like this, and I want you guys to practice. Okay? Pick your form based on the information they gave you. Substitute in what they gave you. You're going to have to find a piece. All right. Here's the last 4. I'm going to put up my answers in about 5 minutes, so I'm going to let you guys work on this independently, then I'll put up my answers, and you guys can start checking your work against mine. All right. I have put my answers up on the screen. Again, the forms down below have nothing to do with the problems above. I just needed room to write the forms.
I'm trying to find a C, but I don't know what to do to try to find it.
You have this, right? What is that telling you? X and Y. So put that that in for x and for y. Absolutely, bathroom passes right there. Go through that one then. All right, guys, we're going to go through this last one, part H, and then I do want to scoot us forward on in the lesson today. We can come back and revisit these types of problems later, too. All right, so it tells me that the K value is 0. What form do I want to be using if it's telling me about a K value? Vertex form. So I'm thinking y equals A times x minus h squared plus k. It tells me that a is 2 and that k is 0. So I've got that much to work with. Yeah, then they give us this ordered pair here. We're going to put 0 in the place of the x and 50 in the place of the y. Absolutely correct. I'm not going to put that plus 0 on the end anymore, because if it's plus 0, I don't need to include it. First thing I would do here is I would divide both sides by 2. Let's get that out of the way. So that would give me 25 is equal to, what's 0 minus h? Negative h, and then it's being squared. When I take something and I multiply it by itself, h squared, and it's going to be a positive, right? what is the square root of 25? 5. So 5 is equal to my h value there. Let me see. Technically it's plus or minus. Let me see if we can figure out why I have plus 5 there. $0.50. Honestly, I think that one could go either way. Let me pull Desmos up and see. 2x plus 5. Okay, it has to go through 0.50. So if I go to Desmos, you know it has to go through 0.50. I have y equals 2x plus 5 squared. Where's 0.50? Way up here. Does it go through 0.50? Yes. If I write the equation, oops, as x minus 5 squared,
Yes.
that one also goes through 0.50. Thank you. So either way, whether you use the plus or the minus, it gives you the correct answer. So this one you could have plus 5, or you could have y equals 2 times x minus 5. That would also be correct. Because correct, we wouldn't put both the plus and the minus sign. If it was if we were just talking factored form instead of vertex form, then yeah, I would have one with a plus and one with a minus. Absolutely. All right. So everybody should now have a whiteboard and a marker. Oh yeah, absolutely. There you go. Whiteboard and a marker and eraser. You guys are going to want it on the graph side. So grid side up. I want you to draw 2 different quadratic graphs. Draw 2 different quadratic graphs. They should look quite different from each other.
Okay.
That's the only direction so far. So on the grid side, 2 graphs, both quadratics. Thank you, ma'am. What does a quadratic graph look like? What shape are you drawing?
A U.
A U. This is a parabola. So draw me 2 parabolas that look quite different. Ooh, I like yours, Justice. Mia, I like yours. Barry, I like yours. I like yours, Niles.
You see? Okay.
Love 'em. Nicely done. I've got to put that away. Thank you, Papa Sangre. Yes. Absolutely. Is that one just plain dead? Not super great. Okay. Do you want another pink one? There is another pink one right there. Okay.
You want to go to some more?
Yeah. It's on its way out anyway. All right. So there's a couple that I want to grab and hold up. I'm going to steal yours because they're close. Let me find another one that I want to look at. promise I'll give the boards back. Two parabolas, both U-shaped, right?
Yes.
Tell me about similarities and differences.
Is this the one where it's
One
like
is
stretched?
negative.
Yeah.
Oh, yeah.
One looks like it's been compressed, one looks like it's been stretched. What else?
One's negative, one's positive.
One's negative, how do you know which one's negative?
It's facing down.
It points down. If they point down, does that mean they have a highest point or a lowest point?
A highest point.
Yeah, if they point down, then they have a highest point. What do we call that highest point?
The maximum.
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 Does this one have a maximum?
But it has a minimum.
It has a minimum.
Because it goes forward.
Yep, this one points up, so it has a lowest point. That would be a minimum. In this case, the minimum and the maximum here, even though one points up, one points down, I can still use one word to describe minimum or maximum. What word could I use, even if I don't know which way it's facing? Vertex. All right, I'm gonna hold for another one. Can you guys see this one okay?
Yes.
Similarities and differences.
Both facing.
Yeah, they're both negative. They both have a maximum.
Both shifted over. One of them shifted over.
One of them is shifted over to the right. What value in an equation would shift things to the right?
Negative.
Our h value. From vertex form, the h value would shift it over. If we were in standard form, that would be the b value that would do that shifting. We don't have formal rules for that. We know how AH and K work, but if we change it into standard form, that's what it would be. All right. Where did my thing go? There we are. Without doing any math, and you can flip over to the other side of your board now. I want you to tell me the key feature for the graph. So I want you to give me the coordinates, that would be an ordered pair, and I want you to tell me what that feature is. So what do we know if it's in standard form? What do we know if it's in factored form? What do we know if it's in vertex form? I'm going to give you guys about 2-ish minutes. I want to know the name of the key feature. So what is it that I can tell about the graph? And I want the ordered pair that goes with it. Let's do one of them together. Let's look at vertex form. Vertex form tells me about what key feature? The vertex. Vertex tells me about the vertex. Where would the ordered pair be for the vertex? Where could I find the vertex of this graph?
5 and 8.
H and K, so 5 and negative 1.
I was wrong.
Because remember, your vertex is HK. But the vertex form equation has x minus h in it. So we're always like, ignore the minus sign. That's your h. So that means if you see a plus sign, it's really a negative there. What kind of information do we know about the graph because of factored form?
Intercept.
Yes,
Oh.
intercepts. tells me about the x-intercepts. How many x-intercepts does this graph have? 2. Can you tell me the ordered pairs for them?
-4 and -6.
So close.
Positive 6.
Yep. +4, +6. What would the other part of the ordered pair be?
0.
Zeros. X-intercepts always have zeros where the y goes. Standard form's weird. Do you know what standard form tells us?
If it's positive.
It does tell us if it's positive or negative.
Okay, that's the only thing.
What'd you say, Niles? Y-intercept. A y-intercept looks like what? What does that ordered pair look like? 0 and then some number, right? 24. How did you know it was 24? Yeah, because if I put 0 in the place of x, it's going to just equal 24. So my y would be 24. All right. What's the same and what's different about these two?
Oh, it has an A.
It hasn't. Do they both have A or just one?
They both have A.
They both have A. What's the A value for this one?
1.
-1.
-2.
-2. Is that the only thing that's different?
No.
Here I have +4 and +4. Yes, both A's are negative. So what does that mean about the graph for this one over here?
It'll be shifted.
It's going to be upside down, right? Because it has a negative A value. Is this one going to be upside down?
Yes.
Is it going to be the same,
It's gonna be wider.
wider or narrower? Narrower. Why is it going to be narrower? Ooh, that's really horrible. Yes.
What?
When we have whole numbers, that's a vertical stretch. I don't think I have a very good example here. Hopefully I don't break anything. Oh, a rubber band will show this. Watch me break my rubber band. Okay, so if I have a rubber band and I stretch it vertically, what happens to it?
Expand.
The whole thing gets
Bigger.
skinnier.
Oh, skinny, yeah.
But if I take my rubber band and I compress it, I squish it, what happens? It gets wider. That's why the fractions make it wider. The whole numbers make it skinnier, because we're talking about vertical stretches and vertical compressions. There we go. Have you guys ever played dominoes before?
Yes.
Yeah.
I don't know how to play the old people game.
That's what I want to know. So not just can you stand them up and knock them over, because that's super fun. How do you play an old people version of dominoes?
I
You're
don't
supposed
think.
to like compare to
Yeah. So if I have a domino, guys, pay attention because tomorrow you're going to play dominoes with some stuff. I'm serious. All right, so if I have a domino like this, and so dominoes have 2 sides to them, right?
Yeah.
And then I have these 2 dominoes that I could choose to play. How would I do that?
the 2-sided would have to go to the other 2 sides, right?
Yeah.
Or have I been playing it wrong?
So,
So the one with 2 dots would go.
I don't know how they
with
put
2 dots.
yeah, so I would have to match up, like these numbers right here, if they touch, they've got to have the same numbers on them. So it has to represent the same thing. The blue one over here has to touch like this, because these 2 have to represent the same thing.
What's the point of the? How do you win?
Doesn't matter.
Oh, yeah, how
put
do
it
you
like
win?
up or
Nope. Does not matter. As long as it's touching the thing that's the same number. So I've got like 3 sides to choose from. I don't remember how you decide who wins.
What the?
I think it's
We're just gonna be
whoever
matching
got the
stuff
more
forever.
matches.
Yeah, I think it's whoever has the most matches on the board. You guys are going to play dominoes with some quadratics. So tomorrow when you guys get in here, I'm going to match you with a partner. You're going to have to cut your dominoes out. Please remember, dominoes have two sides, so don't just cut them all into little rectangles. You should have rectangles with two sides, and then we'll work on matching those dominoes.